Now let me talk about posterior distribution-based measures to provide information about, Bayesian inference and model selection. A couple measures I want to go over. First is called credible interval. Credible interval is the Bayesian counterpart of confidence interval in the frequent statistics. And next one is called highest density interval. Sometimes it is abbreviated as HDI. And last one I want to talk about is regions of practical equivalence and the combined implementation of what is called HDI plus rho for a Bayesian assessment of non-values. So what is credible interval? Credible interval is the Bayesian counterpart of confidence interval in the frequency statistics as defined in the previous slide. It provides a real probability for the central range of parameters. It is a probability, unlike the confidence interval. So we can say something like the probability for theta for a parameter of interest or quantity of interest to be between A, that is lower bound, and B, that is upper bound, is 0.95. So we can provide a real probabilistic statement. And in some cases, I don't say the majority of cases, but in some cases, it's credible intervals are equal tail intervals. It is they're equal amount of empirical cumulative density into tails. Next is what is highest density interval? It is an interval estimate of the posterior within which densities are higher than those outside the interval. And it does not have to be symmetric or equal-tailed. Here I'm talking about the distribution of density, and sometimes we can have multimodal distributions. In that case, it can be symmetric. Next is regions of practical equivalence. Regions of practical equivalence refers to the range of values that are empirically equivalent to the value specified in a noun. So in a lot of cases, the noun value is 0, but we argue that with that, region, okay, or range, we argue that any values falling within that range are practically equivalent of the noun value. And practically, in this case, if the noun value is 0, that is practically all these values falling within that range considered to be what? No effect. And it is usually symmetric with a preset radius. For example, let's say the noun value, theta 0 here is 0. We say the effect, for a parameter is 0, the noun value, okay? Then with plus or minus 1/10 of standard deviation, okay, within that range, if theta falls within that range, then we argue that it is, practically equivalent to 0, or no effect. For example, let's say for the distribution of IQ with a standard deviation equal to 15, then for a value, IQ value that is not different from the mean, which is 100, then we need to have a region of practical equivalence set to 98.5 to 101.5. Okay? So in that case, we say it is, equivalent of 100. Well, the question is, how to set the radius, right? Here, the example is plus or minus, tenth of standard deviation y. Is that a reasonable radius? Okay, so let me go through